Hello everyone. Today we are going to discuss about applications of smart grid technology. In last video we have discussed about the smart grid technology. The smart grid technology is the talking about the advanced electrical grid where we are using digital technology and automation technology to have better communications. So it means that we have a traditional grid where the communication is not possible, only the power flow is possible. But in modern grid is we call smart grid where we embedded the communication channel through the Wi-Fi network, all sort of things. This is possible only because of the digital technology and automation technology. So each device, let's say a meter, voltmeter, which reads the parameters that can be communicate with the control center in real time. So communication happens at the control center in real time. Active power, reactive power, voltage, frequency, every parameters in real time it communicate with the control center. So let's look at what are the applications of smart grid technology. So urban smart grids. So cities benefit from smart grids by reducing outages, managing peak demands, and improving overall energy efficiency. So usually the urban cities usually uh, get better benefit managing peak demand, improving overall efficiency, especially as urban areas continue to grow and add more renewable resources. We said that smart grids provide the opportunity to add more renewable resources. They are fundamental for smart city initiatives where energy management is integrated with other infrastructure systems like transportation and water. So in modern the infrastructure development, not just the energy infrastructure, we can integrate the energy infrastructure with the transportation, water. So it is like a highly integrated system. That in that cases, we need the smart grids because smart grid can be communicate in a better way. Like we have a good communication. So basically, it's not just the grid or the supply and demand. There is a communication between the systems. Okay, smart grids enhance rural and remote areas. Talking about rural and remote areas, smart grid enhance reliability in rural areas by reducing line losses and managing distributed energy resources like local solars and wind turbines. Okay, we know that the line losses is a big problem in transmission and distribution. So if we have a smart grid, it is better manage the reliability by reducing the line losses. And also we can integrate the solar and the wind power generation. Those are renewable power generation in we call the distributed energy resources, DER, we call DER. And in remote regions, they can improve the viability of microgrids, enabling energy independence and reducing reliance on long transmission lines. Earlier, we have provided few videos about microgrids. So if you want to engage in the microgrid concept or microgrid design, then we need a smart grid technology because microgrid is the system where we can generate power independently. We can manage a local area like a, let's say 10-kilometer radius of local area independently, or some cases we can connect with the grid. Like there's a choice, grid become a choice to our local network. That's called microgrid. So it provide the energy independence. So those the new technology, if we want to adopt to new technology of microgrid, our grid should be smart. So if, with a smart grid implementation only, we can go with a microgrid uh, adaptation. Okay. Then we can talk about industrial applications. Manufacturing and data centers benefit from smart grids through reliable power and dynamic pricing, helping them manage energy costs and optimize operations. So dynamic pricing is not possible without the real-time data. So data centers, all sort of things get benefit from smart grids, and dynamic pricing is possible, reliable power is possible through the smart grids. Smart grids also help industries meet environmental targets by integrating renewable resources and optimizing power use. So we know that the corporate social responsibility CRs through the CSR responsibility, they need to reduce the carbon emission. I mean, they need to reduce the heating effect of environment. So in order to protect the environment, every industries has to reduce their energy consumption, or they can you reduce the energy consumption which comes from non-renewable resources. So by integrating more renewable resources, we as a power system engineers helping the environment to reach the target, that is net zero emission target by 2050. Many countries having this net zero emission target. It means like we are not going to produce any additional emission to the environment by 2050. So to reach that target, this smart grid adaptation, it will help in a better way. Then electric vehicle integration. So smart grids support EV charging infrastructure by managing charging schedules, balancing load, and even allowing EV to discharge energy back into the grid. So we know the electric vehicles are very famous nowadays, and it is a new evolving technology. So EV charging infrastructure is another addition in the power system. So smart grids provide the opportunity to add EV charging stations, and it provide the schedules of charging, balancing load, and sometimes it can export electricity to the grid from the EV charging station. Whenever there's a need come, grid need energy, we can send back to the grid through the EV charging. Okay, EV can discharge, electric vehicle can discharge the energy to the grid. So that's also possible. As EV adoption grows, smart grid will play a key role in managing the additional demand, ensuring efficient use of renewable energy. So with the smart grids we can do all this sort of things, because the key idea is we need to charge the EV electric vehicles whenever the electricity demand is low and the price of electricity is low. I mean the off peak hours, usually off peak hours we need to charge. So off peak hours is not defined, like every day the off peak hours may change. We usually say off peak hours is 6 p.m. to 9 p.m., but in certain days it may shift. So if we have a real time data, we know that today what is the demand, when I can charge my electric vehicles, so in a cheaper price. So all sort of things play an important role in energy management. In that case, smart grids provide the data, real-time data, so every moment, and we can plan it with a prediction. We can plan it when to charge, when to discharge from the EV station. So this provide the support for the renewable energy adaptation as well, implementation as well. We come to the last slides. So what is the future of smart grids? The smart grid is an essential component of energy transition, enabling a cleaner, more resilient, and customer-centered energy system. So it should be cleaner, that is a renewable, more resilient, and customer-centered energy system. So future advancement in AI, machine learning, and IoT, Internet of Things, will further enhance the capability of smart grids, because we already have a smart grid with a digital technology and automation technology. Now we have the future technologies that's coming. I mean, evolving artificial intelligence, machine learning, Internet of Things. So these also involved with the smart grids, and they enhance the capability, smart grid capability, making them even more responsive and reliable. As renewable energy and distributed energy grows, smart grids will be indispensable in maintaining grid stability and accelerating shift towards a sustainable energy system. So because when we have produce more and more renewable energy sources, we definitely need the smart grid to adopt this new renewable additions. So that is we come to the end of the slides. That's all for today. Thank you very much. Please subscribe this channel and continue watch this channel.